Good morning. Happy Tuesday. Today we're going to continue to focus on the fourth and final transformation. We're going to be focusing our work today on the dilation. So already you should have read the objectives for today. The first objective told us to understand that a dilation is a transformation which changes the size of a figure by making it larger or smaller. An important thing with the dilation is to know what the scale factor is. The scale factor will tell us how many times larger or how many times smaller each side length needs to become. And today we're going to take a look at why the dilation is not going to be considered a rigid transformation. The first three transformations we did, the translation, reflection, and rotation, were all rigid transformations because they didn't change the size or shape. They were congruent to each other. For dilations, because we're going to change the size, the image is not going to be congruent, but because the shape will not change, the shape will remain the same, we're going to be able to call the two figures similar to each other even though they are not congruent. For your exploratory problems today, you were asked first to take some points and you were just going to dilate a point. That means change the distance of that point. In this case, all of the points, we're going to change the distance from the origin. So you and your partner, if you were asked to take the purple point and double the distance from the origin, so again, I'm going to read through that, take the purple point and double the distance from the origin, that's the same thing as saying do a dilation with a scale factor of 2. That says double the distance from the current purple point to the origin for our new purple point. What's that going to look like? Right now, if we take a look at the graph, our origin is the center of dilation. And I look at point P, I see it's 2 units above the origin. Sorry, this is slow loading. Point P is 2 units above the origin. So the new point P, P prime, is going to be double that. 2 times 2 is 4, or twice the distance from the old one. So you should have had P prime up here. We're going to take a look at part 2 very quickly. Part 2 says to take the green point, and this time we're going to triple the distance between the green point and the origin. That's another way of saying dilate with a scale factor of 3, with the center of dilation being the origin. Triple the distance between the origin and the green point. This is trickier because it's got both down distance and sideways distance, a y value and an x value in relationship to the origin. Right now we know the green point is currently 1 unit to the right, so the new green point is going to end up being 1 times 3 or 3 units to the right. And we see that because the green unit or the y value for the green point is 2, 2 times 3 is 6, the new y value is going to be all the way down at -6. So our new green point, let's zoom out for just 1 second, our new green point is going to be way down there, a x value of 3, a y value of -6, and that is triple, 3 times the distance from the origin as the original green one. The last dilation that you were asked to do, take the red point and decrease the distance by half. So we see the red point up here. We want to cut the distance between the red point and the origin in half. That's another way of saying dilating with a scale factor of 1/2. So if our scale factor is less than 1, a fraction like 1/2, we're going to close the distance between the red point and the origin. The red point is 4 units to the right. Half of that would be 2 units to the right. And the red point is also 6 units above. Half of that would be 3 units above. So I know 2 for x and 3 for y is half the distance of 4 and 6. So that's where r prime should have been located. I would encourage you at this point, if you struggled with part B, again, try to do part B now that we've discussed part A together on your own or talk with your partner. So feel free to pause this video before I run through part B quickly. Part B, instead of being given points, this time for part B as we take a look, we're given 2 shapes. The original red shape, ABCD, this red rectangle, and then the new green rectangle, ABCD, that is a larger green rectangle. Our first question was what kind of transformation took place? Anytime we see the size change, the only transformation that changes size is the dilation. Because the size changed, I know this is a dilation. And then we're going to get in more specific to this dilation and what actually happened. You're asked to fill this out, the length of AB, if I count, and I'm going to go through this quickly, but if you go and count on this graph, the distance from A to B, line segment AB, 1 unit, 2 units. The distance from A to B prime, the new A to B, is 1, 2, 3, 4 units. So we see that that doubled from 2 to 4, from the old AB to the new AB. The original BC, the red BC, is 1, 2, 3, 4 units long. And then we see the new BC up at positive 4, all the way down to negative 4. 4 and 4 gives us a total of 8 units for the new BC. So when we're asked what was the scale factor for the transformation that took place, we see scale factor says each side length, what happened to it? We multiplied it by a factor of 2. Each side length became twice as long. The final question, we're going to get into this more this week. What was the center of dilation? So focusing quickly, what was the center of dilation? And the hint tells us center of dilation, that's going to be the point where everything either expands from or contracts towards. In this case, we're expanding. Our dilation scale factor is 2. So as I take a look at this graph, I see from old A to new A, old B to new B, old C to new C, they're all running away from the origin. The origin is our center of dilation. It's not always going to be the center of dilation. We're going to talk more this week about sometimes the center of dilation is a point other than the origin. But for today and a lot of the work, often we'll see everything grows or shrinks away from the origin. Let me or Ms. Stewart know if you have any questions. Thanks for watching to the end of the video. Good luck on the rest of the work today.